Technology is changing how we build products. For a long time, UX focused on screens. It was about where to place a button. It was about making a flow of clicks feel simple and intuitive. Users saw a static interface, they learned its rules and knew the predictable outcomes. The system was a fixed tool. The user made the decisions. This screen-only era gave us a solid foundation. It taught us consistency. It taught us feedback. It taught us clear visual hierarchy. We mastered guiding users through defined tasks with minimal friction. Now, that world is expanding. We are moving from predictable clicks to intelligent copilots. AI is here, embedded in everyday products. AI can suggest a reply to an email. It can draft a report. It can take actions on our behalf. But AI is different from a simple button. Its suggestions are often probable, not certain. That means the system can be wrong. Models and data are constantly changing. This introduces uncertainty into design. New computing paradigms like quantum will amplify this. This fundamental change requires a new playbook for designers. We can't rely on old screen and click rules. When systems generate content and act autonomously, the relationship changes. It becomes less about direct manipulation and more about collaboration. The user is no longer just a user. They become a manager. They become a director. They become a partner. Designers must build this partnership on trust, clarity, and control. Trust, clarity, control. We must ensure people always feel in charge. Designs must show what the system knows. Designs must show how it arrived at a conclusion. Designs must show what its limitations are. This essay gives you a map for this new territory. We'll walk through why UX must change now. Then we'll explore 6 new rules for designers. For each rule, simple, practical steps, and real-world examples. The goal is to demystify designing for AI, to give a clear course to build powerful, trustworthy, helpful products. The outcome, not just better AI, but more human-centered products that empower people with confidence. The first new rule is to design for uncertainty. In the past, if you clicked Save, the document saved. The outcome was 100% certain. An AI system, however, operates on probabilities. When it suggests a headline for your article or a summary of a long report, it is making a statistical best guess. It is not stating a fact. Pretending this uncertainty doesn't exist is a mistake. It breaks user trust the moment the AI gets something wrong. Hiding the probabilistic nature behind a mask of false confidence causes frustration and abandonment. Instead, we must embrace uncertainty and make it visible and understandable. The key is to communicate confidence levels simply and honestly. Avoid complex mathematical scores or cryptic jargon like p-value equals 0.85. Use plain language instead. Likely match a good suggestion. Low confidence idea. These cues help manage expectations. The AI is a helpful assistant, not an all-knowing oracle. Labeling sets the stage for an honest, collaborative relationship. Designing for uncertainty also means giving users clear pathways to act. If a user is unsure about a suggestion, provide immediate low-effort options. Show one alternative or 2 alternatives alongside the primary suggestion. A simple Show Other Options button lets users explore. Provide ways to ask for proof or context. A small why this suggestion. Link can reveal the key info the AI used. Example, a travel app suggests a hotel. Explanation, based on your previous stays in hotels with pools and free breakfast. Practical steps. First, map out the AI's confidence levels. Then, translate those levels into simple, user-facing labels. 70–90%, present as an idea with alternatives. For non-near certainties, design a plan B into the interface. This could be an explicit See More Options button or a subtle cue that other choices exist. Make uncertainty visible and manageable so users feel confidence and control. The second rule is to design for trust. Trust is not a feature you can just promise in your marketing copy. It is not a magical feeling that appears on its own. Trust is an outcome, earned moment by moment through careful design choices. In the world of AI, systems can act in surprising or opaque ways. Designing for trust is one of the most critical jobs a designer has. Every interaction can build trust or erode it. Users need to believe the Copilot is competent. Users need to believe it acts in their best interest. Users need to believe they can understand and control it. A core pillar of trust is explainability. Provide a short, simple reason for each significant suggestion or action. Keep it plain language, a brief because statement. For example, a music app suggests a new playlist, because you listen to a lot of 90s alternative rock and artists like Pearl Jam. That small context makes the AI's thinking transparent. It shows the system is operating on a logical basis connected to the user's data and preferences. Another critical component is control, especially the ability to reverse course. Nothing breaks trust faster than a permanent change the user didn't want and can't undo. A prominent, easily accessible undo button is non-negotiable. Undo acts as a safety net and encourages experimentation. It reduces cognitive load and anxiety from, "I have to be careful," to, "I can try this out." Put this into practice. Create a trust panel for your AI features, a small consistent UI element that appears alongside suggestions. The panel should answer 4 questions at a glance. First, what is the suggestion? Second, why was it made? The because statement. Third, what data did it use? For example, based on this document. Fourth, how do I undo it? Standardize this pattern so users know where to look and stay in control. Trust is built on clear communication and reliable safeguards. It is our job to design those elements into every AI interaction. The third rule is to design for agency. This means ensuring the user is always the pilot, and the AI is the co-pilot. The AI can suggest routes, monitor systems handle routine tasks, but the user must always have their hands on the controls and make the final decisions. An AI that takes over without permission is not a helpful assistant. It is a source of anxiety and frustration. Our goal is to augment human capability, not replace human judgment. The design must always respect this boundary. Users should feel empowered by the AI, not managed by it. This principle is about preserving the user's sense of autonomy and control over their own work and decisions. A practical way to implement this is by designing for different levels of automation. Not all tasks carry the same level of risk or require the same level of intervention. You can create a simple scale, from level 0 to level 5, to define the AI's role. Level 0 is no automation. Level 1 might be a subtle hint, like a squiggly red line under a misspelled word. Level 3 could be a fully drafted suggestion, like a proposed email reply that the user can edit. Level 5 would be full automation, where the system acts on its own based on pre-approved rules. For high-stakes actions, you should always default to lower levels of automation that require explicit user confirmation. Spending money deleting important data. Guardrails are another essential tool for preserving user agency. Guardrails are design patterns that prevent the user, or the AI, from making catastrophic mistakes. The most common guardrail is a confirmation dialogue. Before an AI performs a significant action, the system should pause and ask for permission. For example, if an organization tool's AI suggests, "I can clean up your desktop by archiving 57 old files," it must not proceed until the user clicks an Archive Files button. The fourth rule is to design for conversation and action. Many new AI products use a chat interface as their primary mode of interaction. A user types a request and the AI responds with text. While this is a powerful and intuitive starting point, chat alone is not enough. A conversation is a means to an end, not the end itself. The ultimate goal for most users is to accomplish a task. A successful AI copilot must bridge the gap between the user's intent and a completed action. The design must create clear flows that move seamlessly from conversation to confirmation to execution. Think of the chat interface as the beginning of a workflow. When a user makes a request, the AI's first job is to understand the intent and formulate a plan. The design should then visualize that plan for the user. For instance, if a user types, "Order my usual Friday night pizza," the AI shouldn't just say, "Okay, I've ordered it." Instead, it should respond with an interactive card that shows the plan. "Okay, ordering 1 large pepperoni pizza from Pizza Palace, delivering to 123 Main Street. Total is $22.50. Sound right?" This preview stage is crucial. It gives the user a chance to review the details and catch any errors before committing. After the user confirms the plan, the system should execute the action, and then, this is the important part, show the results. The loop isn't closed until the user sees clear evidence that the task has been completed successfully. In our pizza example, after the user clicks Confirm Purchase, the interface should update to show an order confirmation screen. It might say, "Your pizza is on its way," Expected arrival is 7:45 p.m., along with an order number and a link to track the delivery. This final feedback step provides closure and reinforces the user's trust that the system is reliable and has done what was asked of it. To apply this rule, think beyond the chat bubble. For any conversational request that leads to an action, design a multimodal flow. Start by turning the AI's proposed action into a structured visual component, like a preview card or a checklist. This card should contain the key details of the plan and a single clear call to action button such as confirm or buy now. Once the user approves, design a final confirmation screen that shows the result of the action. By designing these explicit flows from intent to action to result, you create a copilot that is not just a conversationalist but a capable and trustworthy partner in getting things done. The fifth rule is to design for security by default. In the age of AI, security is no longer just a back-end problem for engineers to solve. It has become a critical user experience problem. When AI systems need access to our emails, our documents, and our personal data to be helpful, users are rightfully concerned about privacy and safety. Confusing permission dialogues, hidden settings, and vague promises about security only make things worse. Good security. UX makes safe choices the easy choices. It uses simple language and clear visuals to help users understand what they are sharing and what is being protected. A key principle here is least privilege. This means that any application or AI feature should only request the absolute minimum amount of data and permissions it needs to do its job. If a calendar assistant AI only needs to read your calendar to find open slots, it should not ask for permission to write or delete events. As designers, we must challenge requests for broad, unnecessary permissions. The permission screen itself is a critical piece of UX. Instead of a generic allow app to access your data, it should be specific. Allow Assistant to view your calendar to find meeting times. This transparency helps users make informed decisions. Another area where design can make a huge impact is in explaining new security concepts. We are starting to hear terms like quantum safe or end-to-end encryption. For most users, these are abstract and intimidating phrases. It is our job to translate them into simple, tangible benefits. Instead of just stamping a quantum safe badge on the login screen, add a simple tooltip that explains, in one sentence, what it means for the user. For example, this protects your password from being broken by powerful future computers. This kind of plain language explanation demystifies security and builds user confidence. To put this into practice, start by auditing the permissions your AI feature requires. For each one, ask, is this absolutely necessary? Simplify the language on every permission screen. Create a single, easy-to-find privacy dashboard where users can see exactly what the AI can access and revoke those permissions at any time with a single click. When it comes to complex security topics like quantum computing, work with your engineering team to create one-sentence explanations that focus on the user benefit, not the underlying technology. By treating security as a core design problem, you can build products that people not only find useful, but also feel safe using. The sixth and final rule is to design for speed of learning. AI models are not static, they get better with feedback. The faster an AI can learn from its mistakes, and the faster it can learn from its successes, the more useful it becomes. This learning loop is a design problem. We need to create fast, low-effort ways for users to give feedback on the AI's output. Relying on users to file detailed bug reports or to write long descriptions of what went wrong is too slow and asks too much of them. The best feedback mechanisms are seamlessly integrated into the user's workflow and require just a click or two to provide a clear signal. The goal is to capture simple signals quickly. A classic example is the thumbs up. A classic example is the thumbs down button next to a suggestion. This is a very fast way to get a binary signal. Was this helpful or not? You can make this even more powerful by adding a quick follow-up. If a user clicks thumbs down, you could reveal a few simple choices. Not relevant, incorrect, poorly written. This provides the AI team with more specific, categorized feedback that is much more actionable than a simple dislike. The key is to keep it brief. Users are more likely to give feedback if it only takes a second. Another powerful form of feedback is implicit. When an AI offers a suggested sentence and the user immediately rewrites it, that is a strong signal that the suggestion was not good enough. By designing the system to capture these correction patterns, you can gather valuable training data without explicitly asking the user for anything. For example, If thousands of users consistently change the AI's suggested phrase, utilize the functionality, to the simpler use the feature, the model can learn to prefer simpler language. This kind of passive feedback loop is incredibly efficient and respects the user's time and attention. To apply this rule, build small feedback components into your design system. Create a standard suggestion card that includes a feedback mechanism, thumbs up, down, star rating. Was this helpful? Instrument your product to track correction rates. Measure how often users ignore, measure how often users edit, measure how often users delete AI-generated content. These metrics, correction rate over trust signals, accepting bad suggestions, and regret rate, undoing an accepted suggestion, are vital for understanding the real-world performance of your AI. Fast feedback beats slow perfection. By designing for rapid learning loops, you create a product that evolves and improves with every single user interaction. We are at the beginning of a major shift in how people interact with technology. The old rules of screen-based UX are no longer sufficient for a world of AI copilots and probabilistic computing. As designers, we have a responsibility to navigate this change with care, putting people first. The path forward is not about building the most powerful AI, it is about building the most helpful, trustworthy, and understandable AI. The 6 rules we have discussed provide a framework for doing just that. Designing for uncertainty, trust agency, action security learning. They guide us toward creating products that augment human intelligence rather than attempting to replace it. To help you put these ideas into practice immediately, here's a short checklist you can use for any AI feature you are building. It is called the Clarity Framework. Before you ship, ask yourself if your design meets these 7 criteria. Context, showing what the system knows and what it needs. Limits, saying what it cannot or should not do. Agency, letting the user control and confirm all actions. Reasoning, short because notes and evidence. Iteration, offering ways to refine and try again. Trace, visible history and an undo option. Yield, ensuring the next step is simple and obvious. For those building their first AI prototype, here is a simple capstone checklist to get started. Ensure your prototype includes at least one clear AI suggestion. Pair that suggestion with a small trust panel that explains why it was made. For any action the AI proposes, include an explicit confirmation step and a visible undo button. Integrate a simple feedback loop, like a thumbs up, down, to capture user input. Identify 1 or 2 simple metrics, like correction rate, to measure success. Building a small prototype that includes these 5 elements will put you on the right path to creating a responsible and effective AI experience. The future of design is not about choosing between human intelligence and artificial intelligence. It is about finding the perfect collaboration between the two. Our role is to choreograph that partnership. Use simple words. Keep control firmly with the user. Use small, fast tests to learn and adapt. The goal is to design with clarity and build with trust. Start with a simple AI job description and the clarity checklist. Build small, test fast, and always keep the user in the pilot seat. AI is a powerful new material for creation. Let's use it to build things that are not only intelligent, but also wise, helpful, and humane.